Hey everybody, we're going to go ahead and start on notes for section 9.1. We're talking about circles and parabolas. Remember, a circle is when I cut the top part of the cone. If I look at the very top, it'll create a circle. And then a parabola is when I cut the part of the cone from the side through the base, and it will give me a parabola shape like this. So let's talk about a directrix. And a directrix specifically talks about the part of the parabola that is equidistant from what's called the focus, F-O-C-U-S, and this is the directrix. And from every point on the parabola, it'll be equidistant from the focus to the directrix. So from here, it'll be equidistant from the focus to the directrix. So the directrix is here. It's the line underneath the parabola, and we say it's a fixed line in the it's a fixed line where each point on the parabola is the same distance from the directrix to the focus of the parabola. And so these two things work together. And then a tangent line is a line if it intersects but does not cross a parabola. So it means it doesn't cross into the parabola. So if this is a parabola, the tangent line will just hit it like that. Okay. And so we've been talking about conic sections, but the conic section is the intersection of a plane and what's called a double naped cone. And a double naped cone is kind of like that hourglass that we were talking about, two cones that are touching like this. Okay, so they have different conic sections, so I could cut it like this to make a circle. I could cut it like this to make an ellipse. I could cut it, one of them like this through the base to make a parabola, but I could also cut it like this through both pieces to make a hyperbola. So we've got a circle like this, an ellipse like this right here in this figure, a parabola like this in this figure, and then a hyperbola is actually what happens here. It looks kind of like this in this picture, but we don't see the other side of the cone. For it to be a true hyperbola, there would be another one up above it through another cone. So they're kind of like opposite hyperbolas or opposite parabola. So in the information of the four basic conics, the intersection plane does not pass through the vertex of the cone. When the plane does pass through the vertex, the resulting figure is called a degenerate conic, like a point. So if I cut right through that very tip, it'd be a point. It could be a line or a pair of intersecting lines. So again, if I had two cones and I were to cut them through here, I would have a point. I could have a line like on those cones, or I could have a pair of intersecting lines. Our first conic section is called a circle. We've been talking about this today, and a circle is a plane, all the points on a plane that are equidistant from a fixed point h comma k called the center of the circle. The distance r between the center is the radius. And the standard form of the equation with the center of the circle, which we've been talking about today, is, I'll put this in black, x minus h squared plus y minus k squared equals r squared. We've been working with that today. And the standard form of the equation of a circle, what's centered at the origin, otherwise known as when h and k are 0, are simply x squared plus y squared equals r squared. So for this example, kind of like what we were doing today, the point 0, 1 right here is on the circle, and the center is at -2, 1. If I know it's the center, I also know that it's h, k. Write the standard form of the equation. So I know this is going to be x minus h, which h is -2, squared plus y minus k, which is 1, squared equals r squared, which I don't know r yet, but because these are horizontal, I can count. I know it's going to be 2 for a value of that radius. Or I could use the distance formula, so I get 4 is r squared, and we get x minus a -2 is x plus 2, and y minus 1 squared. Okay, now let's start talking about a parabola. A parabola is a set of all points in a plane that are equidistant from a fixed line which is called the directrix, which we talked about up above in that vocabulary box, and a point or fixed point called the focus. So again, it looks like this. If you've got a directrix and a focus, it's the set of all the points that will be equidistant between the both of them. The midpoint between the focus and the directrix is called the vertex. And we know on the vertex is right here. The line passing through the focus and the vertex is called the axis, or sometimes we call it the axis of symmetry. Hi. And sorry, I'm just finishing up a video real quick. And then the standard form of the equation of the parabola we say is x minus h squared, so very similar to the circle, times 4p, we'll talk about what p is in just a second, times y minus k, as long as p isn't 0. And that's if this is a directrix is a horizontal directrix. And this is, what if the directrix was vertical? Then it would be, the general form would be y minus k. Remember, y and k always go together, equals 4p times x minus h. And h and k, or x and h always go together as well. And this is if it has a vertical directrix. And then the two foci that we are going to talk about, the focus lies on the axis, p units from the vertex. So if the vertex is at the origin, so let's say this is the vertex at the origin, and then it's a horizontal directrix like this, we know that it's a distance of p. So it's going to be x squared equals 4py, which is the vertical axis, or y squared equals 4px, which is the horizontal axis.